I am Tamil Selvi, Professor, Department of Civil Engineering, Rohini College of Engineering and Technology. Third unit, last topic is trigonometrical levelling. This trigonometrical levelling is the process of determining the difference of elevation of station from observed vertical angles and known distances, which are measured to be either horizontal or geodetic length at mean sea level. The vertical angles may be measured by means of an accurate theodolite, and the horizontal distance may either be measured. We shall discuss the trigonometrical levelling under two heads: observations for height and distances, and geodetical observation. In the first case, the principles of plane surveying will be used. In the second case, geodetical observations are used. The first case is plane surveying. It is assumed that the distances between the point observed are not large, so that either the effect of curvature and refraction may be neglected, or proper correction may be applied linearly to the calculated difference in elevation. In the geodetical observation, the trigonometrical levelling, the distance between the points measured in geodetical origin. The ordinary principle of plane surveyings are not applicable. The corrections for curvature and the refraction are applied in angular measure directly to the observed angles. Height and distances. In order to get the difference in elevation between the instrument station and the object under observation, we shall consider the following cases. First case, both the object is accessible. Case 2, base of the object is inaccessible. This instrument station is in the same vertical plane as the elevated sheet. Case 3, base object is inaccessible. Instrument stations not in the same vertical plane as the elevated object. Base of the object is accessible. Here, this is the diagram. The base of the axis is accessible. From this point, let assume that the horizontal distance between the instrument and the object. P is instrument station, Q point to be observed, point CO is observed, A center of the instrument, Q dash is projection of Q on horizontal plane through A, D is equal to A, Q dash equal to horizontal distance between P and Q, H dash equal to height of the instrument at P, H is equal to Q dash. Finally, reduced level of Q is equal to reduced level of benchmark plus S into D tan alpha. Here A is equal to angle of elevation from A to K. Reduced level of Q is equal to reduced level of P plus H plus D tan alpha. If the reading of the staff intercept BM is benchmark is S with the line of side horizontal. Reduced level of Q is equal to reduced level of benchmark plus S plus D tan alpha. Base of the object inaccessible. Inaccessible, set at the theodolite P and level it accurately with respect to the attitude bubble. Direct the telescope towards Q and bisect it accurately. Clamp both the plates, read the vertical angle. Transit the theodolite so that the line of sight is reversed. With the vertical vernier, set 0 reading and the attitude bubble in the center of the run. Take the reading on the staff kept at nearby benchmark. Shift the instrument R and set up the theodolite. Measure the vertical angle alpha 1 to Q with both the face of the observation. With the vertical vernier is set 0 reading and the attitude bubble in the center of its run. Take the reading on the staff kept at the nearby the benchmark. So this is in order to calculate the reduced level of Q. Consider three cases: when the instrument axis at A and B are the same level, when they are different level but the difference is small. So mainly the trigonometric height and distances having three cases: base of the object accessible, base of the object inaccessible, base of the object inaccessible. The instrument stations are not in the same vertical plane and elevated object.